Previously, I said that much effort and education is centered around the dangers of defining variables and functions in the global scope, also referred to as the global namespace, especially when writing JavaScript that will ultimately be targeted at running in a web browser. But I never really answered the question, why is it dangerous? I never kind of ventured into that. And I'm going to illustrate more clearly later on why this is dangerous and how you can really hurt yourself when you are creating variables and functions in the global scope. But in a nutshell, the global scope is global. So number one, each variable that you define in the global scope is not removed from the computer's memory until the web browser or the tab of the web browser navigates to a new web page. So the more that you add into that global scope, the more memory you're taking up, and that memory just is consumed the entire time that that tab is open for that particular web page. But more importantly, number two, again, emphasizing that this is the case with JavaScript in the web browser, not so much true whenever you're building these node style applications. As you load JavaScript that you wrote and you rely on JavaScript code that others write, whether that be code that JavaScript libraries that you've downloaded from the internet or that you include in your project somehow. Maybe they're ones that other people in your company have written and you need to include them in your project, or perhaps even sold commercially online. Some product that you purchased came with a JavaScript file and you include it. Maybe it hasn't been updated in a number of years. The variables and the functions that are defined in those files, when you consider the variables and the functions that you've written in your files, the more that you write at the global scope, the more that they wrote at the global scope. If they didn't take precaution, the more likely you're going to have a collision of names. At some point, somewhere down the road, somebody's going to have a variable named what you named, and they're both trying to contend for for being the variable, the winner in the global scope. So we call these naming collisions. And when these naming collisions happen, either your data will get overwritten by their code or their data will be overwritten by your code. But either way, undoubtedly, it'll cause unanticipated bugs that are difficult to track down and quite frustrating. And the reason why this is even a thing is because it's happened. Okay, so now that it's happened, everybody is extremely concerned about it. And so a series of suggestions came out, and a lot of effort went, again, around trying to figure out how to solve this issue, given the tools in JavaScript that they had available. And the first one that has come out and that I've recommended from the very first lines of code that we've written is to use the let keyword instead of the var keyword, because the var keyword will attach variables to the global scope, which in a web browser is the window object in the document object model. We'll talk about that a little bit later. It's also recommended that you use the technique, the design pattern that we're going to discuss in this video whenever you're writing JavaScript code. Or there's a third option too, which is new in JavaScript, in the latest version of JavaScript, called modules. Unfortunately, and I may even talk about this at more length later on, the implementation of modules is a little bit uneven between Node and the web browsing environment. So I'm not sure how helpful that would be, at least as we're getting started and learning about JavaScript. Just keep in mind that there's several different attacks, but this is probably the one that you'll see used most often in at least JavaScript that's been written over the course of the last 5 to 10 years. But there are some newer ways to tackle this. All right. So, at any rate, the technique that I'm going to discuss in this video, or the design pattern, actually uses a couple of techniques that we've learned about so far. We're going to use an IIFE. Remember what that is? An immediately invoked function expression, to create a function, and then that function will return an object, and that object will have defined functions and variables that will then be kind of scoped to one variable. So instead of having 5 or 10 variables, that will have only one variable in the global scope, or at least in some scope, and then we'll be able to reference the individual variables and variables and functions of that particular object that gets returned. All right, so we'll see how variables and functions can be made essentially private so that we can hide some implementations from the ability for just any code to call them. This is often called encapsulation in software development terms. And so these will be unavailable outside of the public variables and the public functions that we return, and that's generally a good thing. So there will be a couple of benefits that come out of this. All right, so let's get started by creating a new file called module pattern.js. All right, so let's start by creating an IIFE. And to do that, hopefully you remember how to do that. We're going to start with a function expression. We'll just create an empty one to start off with. We wrap it in a set of parentheses, and then we use another set of parentheses to actually invoke it. All right. So what I'm going to do before we get any further is actually set this immediately invoked function expression to a variable. I'm going to call this counter. So I'll set counter equal to whatever is returned. So eventually what we're going to do here is return an object full of properties that have values, properties that point to functions that can be called. But we can also do some private stuff here. And this will not be accessible outside of the calling the counter dot something to access it. And so we can like have a private variable here, like let count equals 0. And we would not be able to do counter.count. It just wouldn't be accessible. We'll fix that here in a moment when we return an object. We'll give an accessor to it. We'll take a couple of passes at that actually. Okay, so let's go and create now a private function as well. And this will just print out a message and style it up a little bit differently. So we won't get crazy here. So console.log. And we'll just say whatever the message is, and then we'll just do like 3 dashes like that. Just a little bit of style, just to show that, you know, we have something here that could be private. But now, ultimately, what we want to do is return an object that will get set to counter here. All right, so we're going to start off simple. We'll come back to this a little bit later because there's going to be an issue with one part of this, actually this part right here. What if I just want to return back the counter, the current value of, or rather the current value of count? I can try that. Again, we'll come back to that in a minute. But let's say we create like an increment property, and it will return a function. And inside that function, we can do something like count plus equal to 1. And then we can call our print method and then just say after increment, something like that. We can also, and here let me use a comma right there because we're going to create another property of our return object called reset. And what this will do is call a function. So we'll create another function expression, print before reset. Then we'll call the count, and then print, or we'll set count equal to 0 because that's the point of a reset. And then after reset, it should always display 0, but let's just double check that. All right. So now we have basically our module pattern. We've created a module, which is essentially an IIFE that returns an object that will expose functions and other properties like the current count. And now here, because I've invoked this immediately, this is available. It's already been executed, and counter now is fully populated and ready to be used in our application. So I can do counter dot value, I think. Wasn't that the name of it? I've forgotten everything already. Okay, yeah, value. So console.log counter.value. And I could try to do console.log counter.count just to prove that it won't give me anything back. So let's just start there, And we'll go node module pattern. And first time we get an undefined. Why? Because count is not a property of counter. Because we didn't, it's not exposed and it's not being returned in the return object. All right, so that is impossible. Now what we can do, however, or we will try to do, is call counter, counter.increment. You can see it shows up in IntelliSense. That's a good sign. So we'll call increment. In fact, let's call it like 3 times. Whoops. Kind of ended up below where I wanted to go there. All right, great. And then we'll call counter.reset, like so. All right, so let's see what we get this time. It's not going to quite be as satisfying because we're going to get a little issue on these lines here. So you can see after the increment, the value is 1, 2, and 3. But then when we attempt to get the value of counter from this property, count, we would assume it would be 3, right? But it's 0. What happened here? Well, we accidentally created something called a closure, and another little topic we need to talk about in JavaScript. So let's not do that. We're going to need a different way to implement this basic functionality. So can't use this technique. What we're going to need to do is take a different tact, and we're going to implement 2 more functions. Here we'll create a set function, or I'm sorry, let's start with a get function. And get, we'll do something super simple. It's just going to return count. And then, and I did it all in 1 line, could have done it on multiple lines, didn't need to, it's pretty simple. Function, and here we're going to set count equal to some value that's going to be passed in. So here we'll say, we'll accept an input parameter called value, making sure we add some commas in between these new properties here that are set to these functions. We'll take in some value and we'll set count equal to that. So we should be able to come down here. And now, since we've kind of removed that, let's go counter dot get, or actually let's set it to the value of 7. Here we'll do a console.log counter.get to ensure that it is 7, and then we'll call our reset. Let's see what we get when we run it this time. All right, this is a little bit more interesting. Well, almost interesting. I need to invoke get. Okay, so I forgot that. Save it, run it 1 more time. There we go. Okay, so here we go. Lines 33 through 35 will produce these 3 lines where we're after increment 1, 2, and 3. Then we call counter set, passing in the value 7. And so we then do console.log get, counter get, and we get that 7 back out. Now we call reset, and before the reset, the value will be 7. After the reset, we reset it to 0. Okay? So hopefully you can see that this technique of returning an object from an IIFE will, first of all, allow us to keep some implementation details private. Like we couldn't get to count, and we didn't try, but we wouldn't be able to get to print because only certain things are being returned. And mostly in terms of functions that give us access to the private functionality and a little bit more. But in addition to that, we've reduced, think of all these variables that we've reduced out of the global scope. There's no count variable now. There's no print. There's no get, set, increment, or reset. They're all part of this one variable called counter. And so there's less of a chance that our namespaces are going to collide as a result of that. Now we want to pick something unique there, maybe something that describes a little bit better what the intent of this is. Maybe something specific to our brand or company, and maybe pick something fairly unique there. But as a result of that, we've protected ourselves and written our code a little bit more defensively. Now, there's one more thing that I want to talk about here, and that is that okay, so keep in mind this technique that I've just demonstrated here is so popular that it has a name. This is the module pattern. There's another variation that was created on this called the revealing module pattern. You might see this used as well. Let's go ahead and create another file, and I'm going to call this revealingmodule.js. All right, and I'm just going to paste some code in so that we can kind of compare and contrast the two versions. All right, so it's very similar in so much that we have an IIFE that we've defined. Inside of that IIFE, we have some private stuff, just like we had before. Here we have some more private stuff. These are the implementations of get, set, increment, and reset. But I've created these as function declarations with names. Now here at the bottom, we have, this is the revealing part of the revealing module pattern. Here I'm revealing publicly accessible functions by including them as properties in this return object. So I can call counter.get and counter.set exactly the way that I could before, but behind the scenes they're calling the implementations that are defined here. And so there's a couple of benefits and a couple of downsides. First of all, what makes it a revealing module pattern is that it reveals the public functions through these properties in the return object, okay? And it's a cleaner, clearer presentation of what actually gets returned. But there is a downside, and that is you can accidentally overwrite. These are just properties, so I could set the value to the get equals 7 and forget the method invocation operator, and as a result I can pretty much just break the association between get and the function name get count, and so that's a downside. We could accidentally break this, whereas in our module pattern you can't really do it. That's not possible. Okay, so that's the module pattern, the revealing module pattern. It brings together a bunch of techniques we've learned, all to the greater good of removing or reducing rather our impact on the global namespace by removing variable names and function names from the global scope. Okay, and we'll see why that's important on the web development side of things as we move in that direction, but wanted to kind of bring all that to a head. All right, so let's continue on in the next video. We'll see you there. Thanks.